to the square root of -1 being labeled I, the imaginary unit, okay? Some of the stuff on this front page is a little confusing, so I'm going to hop down to I squared. All right, what does I squared equal? Well, if I is the square root of -1, what is I squared equal to? -1, because the square and the square root just cancel, right? Okay, so I squared equals the number -1, which is a real number, right? So when we square an imaginary number, we're going to get a real number. Okay? So for example, this is just kind of how we're, this is kind of how we're going to simplify. I'm going to skip over this because the formatting's bad, and we're going to do this on the next page. But anyway, imaginary numbers, things with I, are part of what's called the complex number system, okay? So all numbers are actually in their true form A plus BI, okay? All numbers, if we're looking in the complex number system, are in the form A plus BI. That represents one number, okay? The A, that part is the real component. Okay, so all numbers have a real component, and then the BI represents the imaginary component. All numbers. If I'm working in the complex number system, all numbers can be represented that way. So like, for instance, if we take the number 5, like, you know, good old 5, okay? 5's a real number, right? And in the real number system, yeah, I would just accept that as 5. In its full form, though, the number 5 can be expressed as 5 plus 0i, because the number 5 has no imaginary component. It is purely real. Okay? And then the number, let's just say 5i. The number 5i is an imaginary number, okay, and that number has no real component. So some numbers are purely real, some of them are purely imaginary, and some have a little bit of both. So for example, like the number 2 plus 3i, that is one number, and it's a little bit real, and it's a little bit imaginary. It's got a little bit of both. It's bizarre to think that that's one number, but that's what it is. Okay? Okay. All right, so this Venn diagram might be helpful, right? Like, Venn diagrams, you know this from like English, right? You get how to read those. Okay? So you've lived your whole life here in the real number system. Okay? And that's cool. You've lived all your life, but that is not all there is. Okay? Complex numbers are the bigger piece. You got your real, your purely imaginary, and then the complex ones fill in the voids. This QR code will take you to the video that I just showed you. Okay? All right, so let's simplify each number using the imaginary unit I. Okay? So now we're going to work with this. Okay, so what we do is we look at this and decide what part of this is making this not real. It's a negative, right? So I can reconsider this to be the square root of -1 times the square root of 36. And we know that the square root of -1 is the imaginary unit I. So I'm just going to replace that with I. So this is really going to be I times the square root of 36, which is 6. And to simplify, we're not going to write I times 6 or I6 because this is not an Apple device, right? Simplified, we just write 6i. So the square root of 36 simplifies down to 6i. Okay? Make sense? What would be the square root of negative 25? 5i. Okay? You get it? I mean, like, mechanically, this isn't hard, but conceptually, it's like, okay. Let's do that with b. So we're, again, going to pull out the square root of negative 1 times the square root of 23. The square root of negative 1 is I. And can we simplify the square root of 23? Nope, that's prime. So we just write I times the square root of 23. We're not going to put the I after a square root because it might look like we're square rooting the I, which is like crazy. We're not going to do that. Okay, and then something like this, the square root of negative 48 would be the square root of negative 1 times the square root of 48. We know the square root of negative 1 is I, and we can break up the square root of 48, right? 16 times 3. Yeah, 16 is a perfect square factor. Okay, so that'll be I times 4 roots of 3. But then the question becomes, well, where does the I go? The I is going to come after the 4, but before the square root. So simplified, this would look like 4i root 3. We just don't want the I coming after the square root. Okay? All right, so we're developing a way that we can work with these square roots of negatives. Okay. Now the other thing we have to be able to do is work with complex numbers. Like, you know, when you learned about numbers when you were like little, right? Then you learned how to add them and subtract them, right? Well, we're going back to that, right? We're going to learn how to add and subtract complex numbers, okay? So this is one number. 6 plus 2i is one number plus another number, and the way you do this is just how you would think, like terms. You add reals together and imaginaries together. So this would equal 6 plus 3, which is 9. And then 2 plus negative 5, negative 3. So the answer to this would be 9 minus 3i. Now, you could not say that this is the answer, negative 3i plus 9. You can't do that. You cannot switch the order. Think of it like place value, right? When you were learning about place value, like the tens place and the ones place. If you switch those, that's not right, right? So you can't switch these either. Okay, B, I'm going to multiply this number by 3 and then subtract this number. So just like you think you would, distribute your 3. So 12 minus 3i. And then I'm going to subtract the number 7 plus 5i. Okay? So, like terms. 12 minus 7 is 5. And then negative 3i minus 5i. Yep, negative 8i. So this would be 5 minus 8i. That's not too bad, right? Like I said, mechanically, simple, conceptually, wild. Okay, C. This is multiplication of 2. So now we're going to multiply 2 complex numbers together. All right? How do you think we would approach something like that? Foil, right? Yeah, it's exactly what you do. You foil it. Okay? It's exactly it. So we're just going to foil it. So 4 times 2 is 8. 4 times negative 3i is negative 12i. Pen's coming apart. 5i times 2 is 10i. And then 5i times negative 3i. Yes, minus 15I squared. Okay. Now you can simplify. So you have 8, combine negative 12I and 10I into minus 2I. Okay, now we got this minus 15I squared. Remember from the beginning that we know what I squared is. I squared equals negative 1. So that's really going to say minus 15 times negative 1. Which is 15, right? So it's a real number. It turns real, so I can add it with the other real part. So I have 8 plus 15, which is what, 23? Yeah, 23. So 23 minus 2I would be the solution here, or the answer. Okay? So anytime we have an I squared, that is negative 1. Okay? Okay, can you all try D? Keep in mind that we know that squared means this binomial times itself. So this would really be 6 minus 4I times 6 minus 4I. So you all try that, and we'll check in just a second. Yeah?
Can you factor out like 4?
Can you factor out 4? What do you mean?
Like, I got my answers, but there's like...
Oh, I see what you're saying. No, because we're not solving. So if we were to like divide something out, we're changing the value of it. So factoring is something we do when we're trying to solve. And since this doesn't equal anything, we're not going to divide that out or factor it out because I'm just asking for the answer. That would be like a multiplication problem and the answer is 12, and instead we answered, oh, the answer to this is 3 times 4. You know what I mean? So it wouldn't be technically wrong, but it's just not something that we're going to do. That makes sense. Let's see. What did we get, guys? 20 minus 48I. Yes. Yeah, okay, so that's what she said. I know that we're talking about this in the context of we've been factoring and solving. But what we're doing here is we're going back to like, I'm multiplying two numbers, right? Like if someone said, what is 2 times 6? 12, right? There's no need to break up 12. If someone says, what's 2 times 6? And you say the answer is 3 times 4, right? Like, yes, I mean, sure. Like I could say this is 4 times, what, 5 minus 12i? But I don't need to because it's just asking me to multiply this out. That's the answer. When I multiply this, this is what I get. Does that make sense? Because we're going back, like it's a new number system, so we're going back to basics. Like how do I add, subtract, and multiply with these new numbers? That's all we're doing at this stage. Okay? Okay, let's look at E. Okay, this is going to be something special. 2 plus 5i times 2 minus 5i. Doesn't that look like a difference of squares to you? But a little different, right? So let's see what happens when we FOIL this one out. So 2 times 2 is 4. 2 times negative 5i is minus 10i. 5i times 2 is plus 10i, and 5i times negative 5i is minus 25i squared. Yeah, the imaginary parts cancel out, right? So I'm left with 4 minus 25 times negative 1, which is 4 plus 25, which is just the number 29. So what we're supposed to see is, hey, when I have the same complex number, one with plus, one with minus, it turns out to be a real number when we multiply them. All the imaginary goes away. Okay? So that's something special. Though that relationship is called a complex conjugate. And when you notice a complex conjugate, you don't have to do all of FOIL. We can just notice that our answer, 29, happened from taking 2 squared plus 5 squared. Right? So when we notice complex conjugates, all we have to do is really take the a squared plus the b squared. So here the a squared is 4 plus the b squared, which is 3. So that would make 16 plus 9. So this one would end up being 25. When you notice that you're working with complex conjugates, you can just apply this.
Is it always positive?
It is always positive because whether or not you consider the b to be the positive version or negative, when you square it, it's going to be positive anyway. So that really doesn't matter if I consider b to be negative 3 or positive 3. Squared, it's going to be 9. Okay, and then this one, example 4, would be 6 squared plus 5 squared, which is 36 plus 25, 61. Okay? Okay, now this is important. This relationship is helpful because we might be in a excuse me. We might be in a situation where we need to get rid of all imaginary components. Okay? So we talked about yesterday how you can't have a square root in the denominator of a fraction. Remember that? Okay, well, if I see I, what is I? It's a square root, right? It's the square root of negative 1. So I can't have I in the denominator of a fraction, so I need to remove it. And the way that I can remove it from this whole complex number is if I multiply it by its conjugate. So what would be the conjugate of 2 plus 5i? 2 minus 5i. And I know I can't just do that to the denominator. I also have to do it to the numerator as well because, you know, fractions, that's the rules. Okay? Okay, so with the numerator, we're just going to multiply. So negative 3i times 2 is negative 6i. Negative 3i times negative 5i is plus 15i squared, right? Negative times negative is a plus. I times I is I squared. And then in the denominator, I don't have to do all of FOIL because I recognize that's a conjugate. I'm just going to do 2 squared plus 5 squared. Okay, now I can simplify a little bit. In the numerator, 15i squared is real, right? That ends up being negative 15. So negative 15 minus 6i over 29, yeah. 4 plus 25 is 29. Okay. Now in the real number system, something like this would be okay. We could leave that and we could move on. But in the complex number system, we can't leave it like that. Because the complex number system, everything has to be written in A plus bi form. So the real and the imaginary have to be separated. So I have to write this. I have to split this up. I have to say my answer is negative 15 over 29 minus 6 over 29i. So this is what the math got me. Now I have to put it in the correct form. It's like writing your place values correctly, right? Like you remember you learned like, oh, 21s is 2 10s. You remember that? Okay. I don't know. So you have to separate it. A plus bi form. All right? Questions so far? Okay, part B is very similar, except we have a full complex number on top. So the top isn't the one that's the problem, it's the bottom. So that's the conjugate we need to multiply by. It doesn't matter what's on the numerator, it's the denominator that we have to change. So we're going to multiply by 2 plus 3i. Okay. All right, now in the numerator, we got to do FOIL. Okay. So let's FOIL the numerator. That'll be 8 plus 12i plus 2i plus 3i squared. And I know we can simplify that, but I'm going one step at a time. And then in the denominator, that's the conjugate, so I can just say that's going to be 2 squared plus 3 squared. Okay, simplify that down. I have 8 plus 14i, and then 3 times I squared, isn't that just going to be minus 3? Over 4 plus 9. So 5 plus 14i over, what's 4 plus 9? 13. But can we leave it like that? No, got to separate it. So 5 over 13 plus 14 over 13i. That would be the answer. All done out. You have to separate it because our complex numbers, they can't be, I can't have this divided by 13. I have to have a real and an imaginary. This is the real and this is the imaginary. Okay, so they have to be separate. And what I know that, you know, this is the same thing as like, if it's a common denominator, right? If I added these together, I would get this. But I have to separate it out because I have to have a distinctly real and a distinctly imaginary part to the complex number. Okay? Okay, now these last two are just some SAT kind of like type questions that are just kind of, you know, extra here. All right, so let's see, how could we do negative 4i times 2i times negative 5i? Well, we don't need a FOIL because they're each one term. So it's like if I multiply 3 numbers together, just multiply 2, the first 2, and then multiply the third. So I would just multiply these first. Negative 4i times 2i is negative 8i squared times negative 5i. Can we simplify negative 8i squared? It would just be 8 because I squared is negative 1. Negative 8 times negative 1 is positive 8. So we'd have 8 times negative 5i. So this guy would simplify down to just negative 40i. Okay? Okay, and then B, the formatting is really driving me crazy. This is a square root, and this is a square root. Okay? What do you think we'd do here?
Simplify first.
Yeah. Write this as an imaginary number, and write this as an imaginary number. So the problem is really going to be 3 minus 5i minus 2 plus 9i. And then that's just subtraction, right? So we'd have 3 minus 2, which is 1, negative 5i minus 9i, negative 14i. Negative 5 minus 9 is negative 14, right? Yeah. Okay. Okay. There we go. Okay. So we haven't solved. This is baby steps. We just got to learn how do I work with these kinds of numbers. Friday, we're going to solve equations that end up like this. We're going to get answers for this. But not yet. Not yet. Okay? Yes. Okay. Oh, I got to get tape out.